Good afternoon. This is Tony Dubiel, Technical Solutions Architect for our Cisco Cloud and Managed Services organization. Today we will provide video 5 in a series of videos that incorporate an overview of Intercloud Fabric Business Edition as well as demonstrations. Today is Demo 3, where we will focus on connectivity from my demo lab into Microsoft Azure, along with some interoperability between Microsoft Azure and Amazon AWS. So if we look at the diagram here, we will primarily focus here where I have a dev test environment with a virtual data center that spans across Azure and AWS and the represented customer private data center, as well as an environment where we've spun up a server in Q&A environment and allow for routing interoperability to be localized within Microsoft Azure to route between those two virtual data centers, the Q&A and dev test. And then lastly, I've spun up a SQL server that is a virtual machine that was consumed and purchased from the Microsoft Marketplace to represent interoperability and internetworking between the Azure tenant private IP addressing that is also reachable from a VNIC in the Intercloud Fabric Business Edition workloads that also reside within the tenant environment with a private VNIC on the same subnet. But at the same time, they have the second VNIC that represents the enterprise private IP addressing from the 192.168 addressing that has been extended to the Azure cloud. So on one hand, they're extended as part of a single logical private data center, and then on the other hand, there is interoperability through a DMARC provided through the Azure private tenant network as well. So we'll take a look at all of these in more detail, and hopefully as we unpack them in the live demonstration, it'll all make sense. Just a quick correction here on my slide. The IP addressing within Azure was actually wrong. I had .6 twice. The QA server is on .5 and the dev test server is on .4. And again, they are on the 10.200.0 subnet, which is a common subnet between all three of them. All right, I've logged into the user interface. Or I'm sorry, use the user account to log into the user interface. And what we can see are the virtual machines that are visible from a specific user. Again, using roles-based access, this user 1 doesn't have visibility into the entire environment from a vCenter perspective, but does have visibility into some of the environment, a subset. These are the AWS workloads that have been configured as part of the lab, and these are the Azure workloads. Today's focus is mainly on, or specifically on Azure, so let's take a look at the dev Windows box with a public IP address, as well as the internal enterprise IP address of 192.168.5.5. All right, so we'll take a look at our remote desktop here, 5.5, and connect. 1, 2, 3, 4, 5. All right, so now we have connected to a virtual machine that is running in Azure in our dev test virtual data center. And in this virtual machine, we can go ahead and check out the network real quick as a baseline of what we have in terms of virtual NIC connections and how we connect into Intercloud Fabric as well as into the provider tenant IP addresses. IP config. All right, so let's take a look at this. Our current IP addressing, local area connection 3 is a 192.166.5.5. This is the actual IP address that we remote desktoped in from our enterprise data center into the customer's Intercloud Fabric shell or bubble that exists in Azure. Here's our gateway and the virtual router, so we can route between VLANs. And here is the 10.200.0.4, which is the Azure private IP addressing as it exists for a specific tenant, in this case user 1, with a gateway into Azure's private IP address and tenant network using the 10.200.0.1 address. Okay, so let's just go ahead and see here what we can connect to. All right, so there is a dev test virtual machine running in AWS with a 192.168.5.2 address. Oops. My apologies. Okay, so we can ping a virtual machine running in AWS from a virtual machine running in Microsoft Azure. Let's go ahead and prove that out a bit further and log in remotely, SSH, and log into the virtual machine using this encrypted secure fabric in between our private data center and these two cloud providers. 5.2. There we go. Now, what you'll see here is a 172 address. Again, 10.200.0 subnet is the Azure private IP addressing. 172.31.18.40 is an IP address as it exists in AWS as a VPC, a virtual private cloud, which is the tenant's private IP address that's routable only inside of AWS. In addition to that, we have a VNIC that represents the customer's enterprise IP address, which is on that private 192.168.5 of subnet. That's how we're able to communicate between a VM in Azure and a VM in AWS. This is the AWS subnet, and this is the private IP address that has been provided as part of Intercloud Fabric. And then we have obviously have the routing functionality. If you recall, we do have we have multiple other virtual machines that are running inside of AWS that we could potentially route, allowing a policy to route locally in AWS, or we can keep those VLANs isolated from each other, depending on how we would like to build out those logical virtual data center constructs and what we would like to interconnect or not as part of that. Okay, so let's close this out. And one of the other use cases was having a dev test in a QA environment. QA was on 192.168.2, so we have a .2.5, I believe, and I did allow for a routing policy between these two subnets within Azure. So we'll ping 192.168.2.5, and we are able to route between those two IP addresses. Now this is an abstraction and an overlay. So we're abstracting the infrastructure as a service from Azure in terms of compute, memory, and storage. And on top of that network, we decided to build it as a flat network. We've simplified the Azure private networking. However, we could have built multiple subnets in Azure that would represent the tenant environment. But in this case, I decided to keep it flat and keep it simple using just the default subnet they provide without modifying and customizing that using the Azure portal. However, I could have. But in this case, I've simplified that and then have created an overlay to extend multiple VLANs on top of that single flat network so that we can orchestrate and configure policies from Intercloud Fabric without needing to leverage the Azure tool set. So let's take a look at Azure specifically, and let's depict how we might have built it otherwise. Okay, so we are in the Azure environment. These are the virtual machines. Here's the dev windows, the actual virtual machine that we remote desktop into. We also have a Q&A box that we took a look at. And then I have a SQL server that is running outside of Intercloud Fabric as part of a purpose-built virtual machine that we consume from the Azure Marketplace. Let's take a look at the networking. Currently, I have a single network that was orchestrated through the API originally from that cloud connection from Intercloud Fabric. And what I've decided to do is to continue to use that subnet for other virtual machines, because when you instantiate a net new virtual machine in Azure, it provides you with an option to either create a new private network or to leverage an existing private network. And that's what I did here with the SQL server. I instantiated it using that same network, that 10.200 network. And that's important because I can maintain a flat network within Azure and create these partitions on top of it, as opposed to needing to manage a complicated network that I'm building on the Azure side, and then in addition having this overlay of VLANs on top of that. So I abstract the resources and then manage the complexity from the Intercloud Fabric as I'm building multiple networks using my private IP addressing on top of the Azure environment. Now I could certainly modify this or configure new networks from directly from this portal. So here's where I can go through an exercise of creating additional networks for purposes in Azure. And again, in my use case, I've decided to keep it simple on the provider cloud side, which was the same case with AWS. I decided to use just the default VPC. I didn't do anything fancy by adding additional VPCs on that side. However, I could have. So back to our view of Microsoft Azure, and what I'm going to do is now log into the QA environment from a remote desktop. So the difference here is it's on a different network. Connect. Okay, here is the Q&A box, just for a quick baseline of what we have here. IP config. So again, that's that single private network that I've decided to use for my Intercloud Fabric to create that encrypted overlay and shell on top of is 10.200.0.5, as well as the 192.168.2 subnet is a Q&A subnet that I've put together, and I've allowed it to route to the dev test environment that we showed earlier. Not to be redundant, let's just go ahead and show that again. 192.168.5.5 is my other virtual machine in Azure. And there we go. Let's go back to dev test. Okay, So in dev test, we have two VNICs, Intercloud Fabric and Azure. In Azure, I brought up a virtual machine directly from the Azure Marketplace that does not have the driver and private IP addressing extended to it from the enterprise data center. So this represents either a service or the need for additional capacity where I'm originating this virtual machine in Azure. However, because of the common subnet, I can interoperate and internetwork between these virtual machines that have been migrated previously from the enterprise into Azure with a virtual machine that is instantiated outside of Intercloud Fabric using a DMARC, because of that common VNIC. So if I ping 10.200.0.6, this is a virtual machine that is not, within the bubble, inside the bubble of Intercloud Fabric. Okay, so what we can do from this connectivity is perhaps if this were an app server or a web server, we could certainly query the SQL database that is running within that virtual machine. I purchased SQL licensing in Windows 2000 Server from the marketplace, and actually I'll show you how I did that. And then I can run other applications, perhaps NFS server running in that virtual machine, or in this case I'm connecting to the FTP that's a part of the IIS server. In fact, we can show that could be running a front end web page perhaps. So this is dots. The default web page. Okay, and then we can certainly access FTP again, directly from here. So we can create an FTP server, an NFS server, any other type of file server that perhaps we need access to, and make that readily available in our dev test and Q&A environment. So that's what I did here, is just to show that we can connect to 10.200.0.6, and that virtual machine is actually accessible through a remote desktop. So if I bring up a remote desktop, we can actually connect to it. .0.6. So here is the virtual machine's viewpoint of the world. It has 10.200.0.6 on that private IP address. There is also a public IP address that we can see from the Azure console, what it's allocated, as well as from the virtual machine itself. So this 23.96.124.57 is reachable from the public internet. And we can see the amount of resources that have been allocated to that particular virtual machine. Let's just go ahead and take a quick look at the network to give you some perspective. Again, this virtual machine is not a part of Intercloud Fabric, but we have connectivity, through the private IP. And we have a single VNIC with a 10.200.0.6 that can ping my Intercloud Fabric virtual machines using that subnet. 0.5 is the Q&A server, and 10.200.0.4 is the dev test server. So that would be essentially the underlay, and then the overlay would be the 192 addresses that this virtual machine is unable to have access to because it is not encrypted and it's not a part of the shell. Now, if we were to onboard it, we can make it a part of the shell. So that's a different functionality called onboarding, where we can identify a virtual machine in the provider cloud and modify it by installing the driver and making it a part of the encrypted bubble as part of Intercloud Fabric for a specific tenant and for a specific virtual data center. In this case, we can provide that functionality in AWS in the current release. We need the next release to onboard Azure virtual machines, so expect to see an additional demo here in a few months where I will prove out that use case. Thank you for watching the demo, and I look forward to your participation in my next demo, which will show the ability of using the APIs. So using curl scripts and REST API browser capability to communicate directly with Intercloud Fabric to provision many of the same tasks and functions that we've used the user interface. We can accomplish much of that using the APIs. At the current time, in the current release of 2.2.1, we have a subset of API capability available to us. In the next release, later in July, I believe, as it stands today, we will have full API capability for all of the functions from the UI to be exposed through the API. Thank you, and have a great day.